webinar. So good evening, everybody. Thank you for tuning in to our latest episode of Golang Live, part of the live series events over at Amicus Recruitment. So for those of you who don't know who I am, my name is Jake O'Regan. I am a Golang specialist recruitment consultant for companies across Germany. Over at Amicus Recruitment, we also cover London and Amsterdam as the areas for Golang engineers as well. So tonight's episode of Golang Live is titled Testing in Go, from Basic to Advanced, and I am absolutely delighted to be joined by Anderson de Franca Queiroz, the backend lead over at Blacklane. He's also a Golang Evangelist himself. He will be leading the talk this evening. So we will aim to keep it as interactive as possible. So if people have questions, please ask throughout. And at the right points, I will interrupt Anderson and ask and try and answer questions as we go along. But there will also be time at the end to ask any questions of Anderson as well. So it should last around 30 minutes or so this evening. So without any further ado, over to you, Anderson.
Good evening, everyone. Thank you very much, Jake. So Jake already said, my name is Anderson. Yeah, let's dive into it. So a bit of who I am. I'm Brazilian. I moved to Berlin about 3 years ago. That was about the same time that I started to work with Golang. And since then, I just fell in love with Go. And I've doing a lot of Go. And then now at Blacklane, one of the things that I do is to help to help the company to adopt Go, right? And then the idea today is talk about testing in Go, the tools that Go provide for testing. Understand better these tools and hopefully help to you folks to improve your Go skills and your tests, write more Go-like tests and so on. Right? Yeah, if you have questions, you can ask, and Jake is going to organize and try to interrupt me when it's appropriate, because I can't see the chat and stuff. Okay, so we're going to cover a lot of stuff. Something more basic, and I'm going to go through quicker, and more the final, closer to the final, there's some more interesting things that I will spend a bit more time. So let's go. So just a quick recap. A test in Go is a function, start with test, and then whatever name with a capital letter. For example, it's here, test sample. The file of a test must be end_test.go. And this function receives a pointer to testing t. So what's this testing t? This is basically the thing that we use to interact with the Go command, with the Go test, to say things such as the test failed, skip this test, move to the next one, and so on. And we're going to explore a lot of its functionalities today. So the first things that everyone who writes a test in Go use at least is usually the two functions, errorf or fatalf. They're actually wrappers for fail and fail now. And here already interesting to really see the difference, right? Usually there are two things that happens when a test fails. I want to say, okay, it failed because of that. And sometimes in one test you have more than one assertion, right? Let's say we're testing a HTTP handler. You want to test the right status code was given, some headers, and so on. So if one of them fails, you want to continue the test and check the other ones. However, sometimes something happens and it doesn't make sense to continue testing, and this test should abort. That's when you use fatal or fail now and fatalf. And then this is a quite a detail that helps a lot, because I've seen in other languages as well, sometimes something fails and just log an error, or in that case, people just log with errorf, and the test continues and a lot of stuff blows up. And you don't have to, right? You can just interrupt the test as soon as something fatal happens. Here's just a small example. When you have like assertions, usually you're gonna log errors with fatal. And that's one thing of Go. Usually you explicitly do assertion manually, right? So you create the if, you check whatever you want, and then if there is a failure, you signal that. When I started Go, I felt a bit odd, but nowadays it's so natural to me that I don't even use more the libraries like Testify. They provide like a sugar syntax for that. And here I'm sure like just when the fatal is more interesting, right? Let's say you do some setup and then the setup failed and now you want to abort the test because it doesn't make sense to test anything else. Sorry. And right, so run tests, just go test in the path to the package, or the /./. You can also select a test by regex with the -run, and you're gonna run a subset of the tests. A bit more interesting things. So verbals flag -v, classical thing. It's gonna make the test verbals. One interesting thing, when you're running the test and you wanna log something, you can use log and logf from the testing T, and these functions will only log if the tests are being running in the verbals mode. So it's super handy to put more information when your tests are running, and then you can decide to see them or not when you run the test. And also you can check if the verbals flag was passed by calling testing.verbals, right? So if I run this test here, you see that I'm logging with log t.log, I'm logging with the log package, and I'm doing the test here. So when I run the tests, if I don't run with verbals, I only get like a summary of what happened. And then when I run with the verbals, and then I get the log println, this always printed, but then I also get my log printed with t.log and my one inside the if. And then printing with t.log, you get also the line where the log happened, what can be quite helpful. Another less known flag is -short. So this is quite interesting when I discovered that. The Go already has built in a test to skip slow tests. So the idea that you might have some tests that are slow and you don't want to run it always, just sometimes maybe in your CI/CD, and it already gives a way to separate tests with the -short flag, right? The same way as with the verbals flag, to check for it, you just have to call testing.short and see if the flag is set. What is a short test? This is up to you, right? You decide, and then if you decide to skip the test, you can just call t.skip and pass a message if you want to see the test not being run. So again, so to see how it happens, if you run without -v, you don't see much, but when you run with -v and -short, now it prints that this test was not run. I skipped the test, and then the message that we logged when using t.skip. So this is one thing quite handy to separate tests. Let's see what more. Another really nice thing that happens. Quite often on tests, we do some setup, right? And then we end up creating helper functions, or because this setup's just too big and just cluttering the testing function, or because it's needed for several tests, and then it's better to abstract away, right? And then two things are quite interesting that you can do in Go to make it better. One, some of the setups, they might fail, right? Something might happen. And then if your helper function returns an error, and then you get like in your test to error, if error not new, and so on, and you use 3 lines there that are not really meaningful for the test. So what you can do is first to pass the testing T to the helper function. And then if the function fails, you let the helper function to fail itself. So for example, here, this helper function, if something, of course, here is just a boring example, right? So the only thing that does is to fail. But in case a proper error happens, you can just call t.fatal and fail the helper function and abort the test without having to clutter your test with the code to handle an error. But this by itself is not everything that we can do. When you do that, one thing happens. The Go test is going to report the error in the line that it occurred. But then this line is inside the helper function. And what we're really interested is on the test that failed, and then where this function was invoked, right? So then we have t.helper. Oh, yeah, t.helper for the rescue. With t.helper, you can say to Go test, look, this function that's running now, it's a helper function. So if something happens here, if a fail or something, I want to know, but also I want to know, actually what I want to know is where this function was invoked, because then I know which test was running and exactly in which point of the testing function the problem happened. So when you go to a helper function, you can just say t.helper. And then next time, if you call t.fatal, for example, it's going to fail the test and abort everything. But now, what's interesting, that the line that's going to be reported is the line where the function was invoked. So on this example, of course, you can't see the line numbers. But this line here, marked here, it represents this invocation of the helper function. So precisely on the test and where it failed for the test. So this is something quite helpful that I try to advocate a lot for people to use more. I think it's super helpful. Let's see. Table test. Well, table test is a pretty standard concept. The idea is you have one function that you want to test, and then you have several tests for these functions, and the only thing that's really changed are the parameters that you're passing to it, and of course the output, right? So instead of creating several tests, test function receives positive number, test function receives negative number, you create one test, one table test that has got all these cases inside it. And so how to do that in Go, right? So let's do a small example using the math.abs for that. So the way usually happens, like we create a struct with a name for the test, and then everything that you need, right? The values that we're going to pass for the function and the values that you expect from it. That's what's called our test case, right? So here I'm called TCs, like for test cases. And then each one of my test case, the positive, the negative, and the 0, and what I want there. And then you have a for range to iterate over it. And for each test case, what you do is you call the run method on T that receives 2 arguments. One is the test name, and the second one is just another test function that's going to be the test itself. So here we pass name, and then we are testing math.abs. We pass a value, we get something, we compare, and we mark an error if something happens. So this is the whole test. Things that I've seen already was people to put this whole struct here. They don't even create this variable. I would not do that. I think it's too much stuff in the same place. To have the separation helps the readability. But yeah, it's hardly you're gonna see someone creating like a named struct. You usually just define here in line, because this only makes sense for this test, right? So, and the output. So this is the nice thing. As you pass a name for the test, when the Go test runs it knows there is one like main test and subtests there. So here you can see like the simple table test, and then a summary for every single one of them. So imagine that you have a slow table test or slow test anyway, right? What we can do to make it faster? So here our tests take like 6 seconds to run only 3 tests. There's just something really nice that you can do is to use t.parallel. T.parallel, as the name says, is gonna tell the Go test command to run all these tests in parallel, right? And then you do basically the same thing here. with the table test. The only difference is you're gonna add first in your test function t.parallel, and then assign it to the Go test command. Please run it as much in parallel with the other functions.
So just got a question here, Anderson, if you don't mind.
Yes.
Okay, so it's from Andre. Hi, Andre. Can we throw all tests into separate? Is it Go routines?
You mean spawn? I mean, yeah, definitely you can do that. You could run a Go routine and pass that has got the T, and you launch it to run. But if you just want to run them in parallel, that's a question. So Go already runs already tries to run all the unit tests in a package in parallel, or pretty much, right? With this T parallel, we can parallelize the subtests. But yeah, you could. I don't know if it's gonna be better than use T parallel or something, but there is no restrictions from the language itself, if I understood correctly your question, okay. Andre.
No problem.
But yeah, do the experiment.
That's what
I always say, try it.
No worries at all.
And have some fun.
Andre says, thank you very much, Anderson.
And now, okay, so now we have our test running in parallel, right? Let's see, we run it, and now it took 3 seconds, awesome. However, if you pay attention here, we have this 2 seconds test, it took 3 seconds. And it said running 3 seconds. The same one for the 1 second, and the 3 seconds is fine, right? This is a catch, not for the T parallel itself, but just how the contexts and closures and for loops, they work in Go. So what's happening when you have a for loop? The loop variable, it's always the same. So every time that iteration of the loop happens, a new variable is not created. The same variable is reused, right? And this variable is being captured on this closure here. And this closure, it captures the whole variable, right? Not a copy of it. So anything that happens with this variable is visible inside the closure. And what happens, the Go scheduler is going to schedule the Go routines to run, right? So usually in a for loop, it happens that it goes the whole for loop, and then it runs whatever Go routine was launched inside the for loop, right? Might happen that it's not quite like that, but the easy case, and it happens quite often, right? And then what happens is it runs once, it schedules one Go routine to run. It runs twice, it schedules another one. And every iteration, the loop variable changes. And these Go routines, when they get to run, they see only the last version of the variable, because every time this one got scheduled, and then the loop variable changed, and the second one got scheduled, changed, the third scheduled and changed, and now 3 of them are seeing the last result. So basically what we have to do is create a local copy of the variable to the function that's not going to be visible for the other functions. One simple way of doing that is just rebind it, create like a new variable. And here it works because this TC here belongs to the for scope, and this TC here belongs to this function scope, right? And then rebind it, you have now a copy of it, and then you're safe. And then if you do that and run again, yeah, now we see the test they run properly. And of course, if you write something like that, please add a comment so your fellow colleague that's going to see this line that looks useless, he might not know why, so he do not erase this line. Yeah, another thing that you can do, you don't have to use T-parallel for that, right? You can say to the Go test how many tests can be run in parallel with the -p flag for whatever reasons. And then you can do one thing that's a trick that you might need it, I hope you don't, but you can say P equals 1, and then you run the test sequentially. No test is going to be running parallel because it's going to run at most one test at a time. I've seen code base that use that because the unit tests were so complex, interacting with database and tests and so on, that they just could not run concurrently. And as always, it was too expensive to fix everything, right? So still that way. What else? Oh wait.
Sorry, I just had one question come through again, Anderson. So this one's from Ravi. Hi Ravi.
Hello,
is the source code in this demo available to be downloaded? It looks useful to download and play with.
Yes, sorry, I forgot to mention at the beginning. At the end, there is my contacts, there is my GitHub with the whole source code, the presentations. And as you're seeing on the outputs that I show, if you run the same command, it should produce the same output because everything is runnable. The outputs that I get from the real code that I'm showing and that I use to produce them. The only thing, there are some funny comments in the middle of the code that it's used to make the code appear here, pretty in the present thing.
No worries.
But yeah, all available.
Thank you.
So as we're talking about running tests in parallel, one thing that happens when you have concurrence and things in parallel is race conditions. And of course, Go, being built for concurrence, has got a race condition built in since Go 1.1. And the nice thing that the race detector, it's available pretty much in the whole Go tool chain, right? So you can pass it to test, to run, to build, and to install, right? And it's super, super, super useful. You should let it on by default, at least on your tests, because it might catch things that you do not expect. So you show here one example that I got from the Golang blog. If you just run the test, all fine. But then when you put the minus race, then you get like a huge output. The first thing of the race detect, don't get scared about the size of the output, right? Slowly read what's there. It's easy to understand. So we get like a warning, data race, and then this is super nice, right? So it's saying, look, something was read at a memory address by go routine number 9. There was a write there in the same address by go routine number 8. And here's the stack trace, right? From the operation, when it was written and when it was read. And then it shows to you every single Go routine, where they were created. So the Go routine 9 was created here, the Go routine 8 was created here. And with that, now we can go back to the source code and examine it and see what's happening. Oh yeah, there's a bit more there. Sorry. And trust the race detector, it's super good. It was super handy for me. Once I was fighting the race detector because I was sure that my program didn't have a race condition because I had put the mutex there and it was right. I double checked several times. And the race detector continued to alarm me and say that it was not synchronized by a mutex, until that I realized that one of my methods, I had forgotten the star, and then it was not a pointer method. The receiver was not a pointer, and therefore, this method was using a copy of the mutex. That was another mutex. And that was the reason the code was not synchronized. So it's even good to catch like small failures that, I mean, when you're reviewing the code, you just don't see. Everything is right in one. It was just one missing. So use it. Test data. Bit behind schedule, let's go. So you want to load some data for testing, right? And Go already have a nice approach for that. So test data is a special name for directories that they are going to be ignored by the Go tool. So what that means, that this folder can live with your code, and then when your binary is built and so on, this folder just is ignored, right? So this is not going to become junk in your program. Yeah. So, and then it's the place where you should put your test data. And to access that, the other thing, nice thing is when you are running the test, the current directory is set to the packages directory. So if you access the current directory, is always the package directory. That's where your tests are. That's where your test data are. So you don't have to try to find out I'm in class F, package Y, and my test is somewhere else, and we go back and forth, as I have done a lot of times in other languages to find some data that I had to load. So to load it, it's just, you can call filepath.join and then read the file. The nice thing about using filepath.join instead of writing the path manually, that it takes care to concatenate the path, so it doesn't matter which operating system you are running on, as the goal is going to compile to the right operating system, so it will concatenate the path correctly. So here I'm saying, look, for the test data file below, so do, on my case, here would be test data/hello. And then, yeah, just use it. Super simple. Another quite interesting thing to do in testing are black box testing, right? And we know that in one folder can leave only one Go package, right? So how can I do a black box testing if I have access to everything? Well, that statement is not so true. There's one special package that can live together with other packages. That is the underscore package. So if you have a package, my package, you can have a file in the same folder that has got a package that's my package underscore test. And for the Go tool, this is a completely different package, right? The only difference that you can have both together in the same folder. That way, you can do the black box testing without having to put it somewhere else. And then here, I have this small example. So I have, of course, a package pwd, and then here's the pwd test. And I just import it. Normally, as I would import any other package, and then I can use it. Well, this is not quite a test. It's just to demonstrate that you can do that in the same folder. And then here, if you look later, it's just gonna print the current directory. Oh yeah. So as you see that, yeah, the function prints it. I'm just printing the current directory, and you see that is exactly the directory that I'm running, and then my test data might be and everything. And then another kind of tests that are super important are integration tests, right? And then to help me to define what's an integration test and what's a unit test, I'm gonna use this tweet from Dave Shane. A test is not a unit test if it talks to the database, communicates across the network, touches the file system, can't run at the same time as any of your other unit tests, or you have to do special things in your environment to run it, right? I simplify it a bit like, if you need anything else rather than go mod download, then it's not a unit test anymore. And the main thing is, sometimes you just want to run the test. Sometimes we are just changing a small thing that's covered by a unit test, and you don't need any, you just want to run everything, all the tests, right? But you don't want to have to set up the database or your Kafka or whatever, right? And how do I separate this test if I have everything together? Everything is Go code, right? There are several ideas, and you can be as creative as you want with that. One that I've seen on the internet, but usually is already said that's not the best idea, is to use the minus short flag. You could say, if the minus short set, don't run the integration test, but then you might have a test that is slow, and then you want a proper unit test that's slow, and you want to skip it if the minus short flag's there, right? What I found that's the best is to use build flags. So you basically is gonna tell Go to ignore some source files or not. And another thing that I do as well is to name my integration tests with the prefix integration. So my integration tests are underscore integration underscore test. So I can see in the file, super easy that, okay, this is an integration test. That's something different. And how do you use build tags? This is not build tags. They are not for tests, right? They are for everything. It's just to allow you to use a file or ignore a file at compile time. And you can do a lot of stuff with build tags, and including logic arithmetic. So you can say if this tag, if not tag, or that tag, and you can do super complex stuff. But here, the only thing that we're interested is integration. And then if the flag's passed, you build it. If the tag is not passed, you don't use it. So here's my integration test. So this is how build flags are set. So this is special comment plus build. And then a test and it logs something, right? If I run the test, just the test, I see a warning, no test will run, because I didn't pass the build flag, and this file is ignored. When I add the build flag, and then to add the build flag, just pass minus tags, integration, then the test is run. The only catch here that you might have using build tags is that you have to configure your IDE to know that this should be run every time, right? So your IDE might ignore these files as well when you say IDE run everything or some stuff. But so far it's what have been working me for the best, because then I can really separate stuff. We are almost on time, right?
No problem.
Yeah, let me show HTTP test, and Jake, you tell me how much more minutes I have.
No, you can do as long as you like.
Yeah, okay. The last thing, HTTP test, right? To test external calls and test your handlers. Again, Go have you covered, right? Usually to test a external call, you have to do a lot of setup. Actually, let me go back first. To do test external call, you have to do a lot of setup. Quite recently, a friend of mine came to me, okay, asked, oh, how can I, and he had like a framework for API test, right? Because it mocks this stuff, it receives the request, and then it replies with whatever data you want. How can I do that in Go? And it was like, first, this tool is agnostic of language, right? It just emulates HTTP server. And he, oh, no, but I can configure the tool within the code if it was Java. And it was like, man, you don't need something external. Go already has got it. Really? Yeah. HTTP testing package. So let me show how it works. So this is our function, right? We have a fetcher, it does a get and handle stuff. Simple like that. And you want to know that it does the things properly, right? It builds the right URL. It sends this, it sets the right headers, right? It puts the right body and so on. So this is the whole fetcher. So I receive the URL, it's injected, so I can change it easily. And how I do that? So on my test, I call http test.newServer, that it receives a HTTP handler, right? And here inside, you can do whatever you want, right? So what I'm doing here is I'm parsing the URL and checking the ID, right? And there you can even have the TLS servers. Have a look at the HTTP test package, it's super nice. So the basic thing is every time you call it, you get the server, the test server, and then you immediately defer to close it, right? But you can even have server that didn't start and we start later. That's quite interesting. Yeah, and then when you're gonna do your test to get the server's URL, you just use .url that I'm passing to fetcher, and then my fetcher is gonna call my test server. And then Go takes care to find a free port to run the thing, the others and everything, right? So you don't have to worry about these details. And then, yeah, what do a lot of the times I do assertions inside my handler on my test server. So here I'm just asserting that, you know, the ID that you pass is really a number and stuff, but you can do all sorts of stuff. Check the method, check headers, body, you name it. And here is the whole test, right? So I define my test server, I defer to close it, I set it as my fetcher, I call it, and then yeah, I checked if there was an error there as well. And among these, you can easily also test your handlers. So a handler receives a writer and a request, handler function, and then the HTTP test gives you a response recorder, and then also you can create requests from it. And then later on, it already is a response, response writer. So you can call it .result, and then you get the response that it saved from when your handler returned the response, and then you can test status code, body, and so on. This is super, super handy. And test your handlers, really. Test your handlers. You always catch something. Oh yeah. So also among the tests, there are another concept, that's the idea of an example, right? Sometimes you want to create an example of how to use your code, right? It might be how to use a function that's more complex, or you writing a library showing how to use it. And you can do that in Go by calling it example. This is the same thing as a test. It lives inside a test Go file. But the super nice thing that happens here is the example is also a test. So if the example prints anything to the standard output, you can create an assertion. Just like that. You have your example function and you call it, and you say use this special comment output, and then everything below it Go is going to compare 1 to 1 with the standard output. So if let's say the output's different, so let's say here I expect an output of 3 spaces, and then my function doesn't do that, it fails because it runs together with the tests and says what it got, what it wants. So it's like a super nice way to create documentation. Also, when you do Go docs, these examples are part of the functions, the function documentation. And so you get 2 in 1, right? You show how to use your code, and then you get assertions. I use it quite a lot when I create like a small logging library for Blacklane. And then instead of writing tests and then on how to use it, I just wrote examples. And then I can assess the output. And then you can also have another output as well. So this function is a bit random. It might create 1, 2, or 2, 1. And then Go is going to assert it regardless of the ordering. And then there is a convention of how to name stuff. So you should call example my function or my type underscore my method. Of course, this is a method on the type, my type. And you might have suffix if you want to show several forms of the same method type, for example. Last but not least, tests also, they have a main function. They receive a testing M, and then the main function, you are basically in control on how to run the tests. So to run the test, you have to call m.run, and then it's a super good place to create a global setup and a global teardown. And then m.run returns the exit code, and you should call os.exit with the exit code at the end. So 2 super important things. 1, os.exit does not run defer, right? So don't do global setup, defer, global teardown, right? You do have to do like that. And I know that because I was like, why my global teardown is not running, until I went there and read the documentation of os.exit. And another thing that you have to do, you should do anyways, but mainly if you're going to try to use a flag, like verbal short or any other, one is to call flag.parse. Because when you have the main function, basically took control of the whole test, and Go is not going to parse any flag for you. So you have to say it. If you don't, here's the example. So if you just do it like that, and then you get a problem. We call verbose before parse. Last, go caches test. So if the same test is run twice, nothing has changed, it's gonna cache it. And then the idiomatic way of forcing all tests to run and ignores the cache is to use count -1. That's one flag to say how many times at least a test should be run. So as they have to be run at least once, so you bust the cache. Yeah, I did it a bit over time.
That's fine. Yeah,
and then, yeah, sorry.
Sorry, no, carry on, Anderson. Let's, yeah, please.
Yeah, my Twitter, email, LinkedIn, and then where the talks are.
Amazing.
Right, so you can go to my GitHub.
Well, thank you very, very much, Anderson. The feedback we're getting in is great. So thank you very much for that.
For the opportunity.
No, brilliant. I do have one question so far, and now is the time. If anybody has any questions, please send them through. Also, this is being recorded, so there will be a chance to, obviously, if you did miss anything or you joined a bit late, which I know some people do with connection problems and things like that, then you will be able to watch this back tomorrow. Everybody will receive a link. So the question I have is how to compare deep embedded types or maps in got and want in test. Sunny has asked this question. He currently loops over the maps and checks the keys. Is there any methods to achieve this?
So there are two ways of doing that. If you only go with the standard library, you can use the magic reflect package. Reflect has got a reflect.deep equal is a function that, as it says, it's deeply equal. So it's gonna test everything, right? So they slice the maps, they're gonna test the content itself, right? Not just the address. However, Google has got a CMP library. I think it's github.com/google/CMP. That is like a better deep equal. So this is preferred to be used instead of deep equal. I confess I didn't look at the small details why. It's better, but yeah. But the reflect deep equal is going to work as well. So if you don't want to bring another dependency to your code, go with reflect.deep equal, or instead you can use CMP. Yeah, some nice stuff that CMP has got, like you can ask the diff, and it shows like a pretty diff with plus and minus. You have more. It is more built for tests, right? Rather than the reflect deep equals that's just trying to see if two things are equal and doesn't matter why they're being used.
Yeah, thank you very much. Another one that's come through is, are HTTP tests interchangeable with component tests in terms of meaning? Is there a way to run HTTP tests in parallel without modifying test database in every HTTP test request in order to keep away database status unchanged before every test?
Okay, so sorry, let me.
Yeah, if you want to come.
Read again. No, I opened the chat here.
Okay, perfect.
Test interchangeable with component tests in terms of meaning. Yes, I mean I called here HTTP tests because it's using the HTTP testing package, right? And then you're testing a handler or external HTTP call. But if it is your component, it's a component test. I'm not super hard on classifying tests, right? It's more the idea here. Is there a way to run HTTP tests in parallel without modifying test database in every HTTP test request? So if what you're doing in your test server is not doing anything on the database, that's fine, right? So this at the end depends how it's your setup. So if you're really using a database behind, then yeah, you might have a problem. But I wouldn't use a test server and then inside it access a database or something. Maybe it's the opposite you're saying, right? your function access the database, your local database, depending of how it interacts with external API. Yeah, I mean, you're gonna have to control. Yeah, you can mock the database as well. Yeah, that's a super good thing, right? If you have interfaces, right, and it is gonna pay off one way or another, right? You don't have to create interfaces just because of your test, right? You do that to make a clean architecture and decouple the components, right? So ideally your database is behind the interface, right, of some high level abstractor of store or something. So let's say on Blacklane, right, we have rides. And then let's say that I have a rides abstraction and I can say rides.save or something, right? I don't care if it's going to be saved in a database and an S3 in memory, wherever, right? I let it behind. And then on my test, I mock it. I mock this interface, and then I don't have to use database.
Perfect. And we just have another one here. How would you mock a dependency that doesn't have an API defined as interface?
Mock a dependency that doesn't have an API? What do you mean?
So yeah, this one came from Ivan. It says, how would you mock a dependency that doesn't have an API defined as interface?
You can't.
You can't.
Yeah, long story short. Yeah, no, just, yeah. Is it just an internal component? I don't know if you can do black magic if reflect, maybe, probably, but it's black magic.
No problem. He did say, he just said, I did think so. I just wanted to confirm, so that's fine. Well, I will, everyone's had a chance to ask some questions there. So thank you very much, everybody, for attending. Anderson, it was brilliant. Thank you so much for hosting the webinar. As mentioned, it will be available for everybody to have a recording of if there was something that you missed, and Anderson's details are all there on screen at the moment as well. So please, he mentioned himself, please, if you do have any questions or you do want to check anything over, his GitHub, his LinkedIn's there, please reach out. Also, where to find me as well on email and LinkedIn as well. So Anderson, I think we'll leave it there. Thank you very much.
Thank you very much for the opportunity. Thank you everyone who came.
All right. Well, everyone have a great evening, and I'm sure we'll speak to everyone soon. Thanks very much.
Thank you.
Cheers, guys. Thank you.